Okay, surds. Can anybody tell me what a surd is, or give me an example of a surd? I'm going to have to start picking on people if I'm not getting volunteers. Yes?
An example of root 2.
Root 2. Okay, yeah, that's a surd. Square root of 2 is a surd. Okay? So a surd is a square root of a number where it doesn't give you a really nice answer. So, for example, if we said square root of 9, well, that's just 3. So we don't count that as a surd. But this one here, we do. Because if we do it as a decimal, what can you tell me about the decimal equivalent of root 2? If you reach for your calculator, type root 2 in, get it as a decimal number. Is it a nice number? Does it stop after a while?
No. Okay.
Does anybody know a word beginning with I that we can use to describe this sort of decimal? Yeah? It's not an integer. Okay, so there's an I word that it isn't. It's not an integer. But there's another I word that it is. I don't know if you come across it, those of you who did further. I-double-R. At the back? Go on. Irrational. Yeah. Okay, it's an example of an irrational number. An irrational number is a number that sort of goes on forever in its decimal places with no pattern, no repeat. It just goes on and on forever and ever. So root 2 is a surd. It's about 1.4 something, but root 2 is a surd. Another one, for example, would be square root of 10. If you do that, it goes on and on forever. So that one's a surd. What sort of numbers inside square roots are not surds? What sort of number would it be inside a square root if it was not going to be a surd? Gracie?
Even numbers?
Not just even numbers, because root 10's an even one.
Well, not prime numbers?
Not prime numbers.
Square numbers.
That's correct. I'm looking for something else. Can you extend your answer, or do you want me to go to somebody else? Okay? Square number, yeah, that's right. If it was a square number inside the square root, the example we had of that up here was a square root of 9, because that gives you a nice number. That won't be a surd. Okay? So, irrational numbers, numbers that go on forever and have no pattern. Can anybody give me an example of any other irrational numbers? They're not surds, but you have come across some other sorts of irrational numbers. Yeah?
Is that like fractions?
Fractions, no. Not usually, because often there's a pattern there with fractions. So if you have a third, for example, 1 over 3, 3 carries on forever. There's a pattern there, so that wouldn't be. But there are some other sorts of numbers that you've come across. Tristan?
Like pi.
Pi is an example, yeah. Okay, that's also an irrational number. It's not a surd, but it's an irrational number. It goes on and on and on forever. Any other sort of number you might have come across? A button you press on the calculator that might lead to an irrational number from normal GCSE. Go on.
Like sine of
Yeah.
tan.
Yeah, if you did sine of a number, for example, sine of 55 degrees, that'll give you a horrible decimal number that goes on and on forever. So that's another example of an irrational number. They're not surds, those two, but they are irrational numbers. So, this won't appear on the video, but if I just put this up on the board for the class and press all the right buttons so we see what we should be seeing, and go back to your class. So, Tuesday B, there we go. So what we are doing at the moment, if I get rid of that, in this chapter our aim is to be able to simplify expressions involving square, cube and other roots, and that's going to involve simplifying surds and rationalising denominators. So we'll look at simplifying surds first. If you want to have that as a sort of subheading, simplifying surds. I think I spelt my first spelling mistake already there. There should be an I there, I think, shouldn't it? Simplifying surds. If I told you that the square root of 8 can be written as a simpler surd, anybody any idea what we're going on about? Liv?
Would you like put the factors
the square root of 2 and the square root of 4.
And
So-
then root just be 2 root 2.
Okay, square root of 4 is 2. That I'll just leave as root 2. Times those together, we normally write the whole number first. That is an example of simplifying surds, and I'll go through that in far more detail, don't worry. If you are simplifying surds, what your aim is, if you're simplifying surds, is to make the number inside the square root as small as possible. So the aim is the number inside the square root sign to be as small as possible. So we went from here, an 8 being inside the square root sign, to just a 2 being in the square root sign. So we call that a simplified surd. We've made the number inside there smaller. And what Liv did was looked at factors here, and she chose 2 and 4. There's one particular feature of one of those factors that helped us to do this. Catherine? Not because it's prime. 2 was prime. That wasn't the one we actually changed. That wasn't the helpful one. Square, yes. This number here was a square number. So if the aim is to make the number inside the square root as small as possible, the method that we use is we factorize our number using square numbers if we can. Using square numbers if possible. So, if we look at another one, if we look at the square root of 32, there are various ways we can split 32 up into factors. There's 1 and 32, there's 2 and 16, there's 4 and 8. Those are factors of 32. Which of those pairs has got a square number in it? Or maybe I should actually say which of those pairs has got the biggest square number in it. We have James over here. Can anybody else spot? Look at those pairs there. Which of those pairs has got the biggest square number? Heather? The 2 and the 16. Yeah. That 16 there is a big square number. Or big relative to the 4 down here that was also a square number. So that's the pairing that we will use. So we can say that the square root of 32 is the same as, and I'm going to write the 16 first, the square number first. 16 times by 2, square rooted. So I've written that square number as the first number of the factor. And then if you are multiplying two numbers together and square rooting their result, you can split it up and say, well, it's the square root of the first number times by the square root of the second number. So this splitting up here works when you are timesing, and it works when you're dividing. It does not work for adding and taking away. So the process we used here was we split up, and we can do that. We can do this if we are timesing or dividing. We cannot do that if we're adding or taking away. And we'll do an example just to show that in a minute. I'm just going to write that line down here again. Root 16 times by root 2. So the square root of 16 is 4. Square root of root 2, can't do anything to that, just leave it as the square root of root 2. So simplified, that becomes 4 root 2. Now, you've got calculators, and if you type square root of 32 in, it gives you that straight away. Has anyone told you yet you're not allowed to use calculators in the C1 exam? Okay, you're not. Okay, so that's one reason why we're doing this. So, there we go. That's the first example. So, if we have a look at another one, square root of 72. Can anybody think of ways we can factorize 72, where square numbers are involved in the factorizing? We have Jack, we have James. How about anybody who haven't heard from yet? Callum? 36 and 2. Well, 36 is a square number, yeah, that would work. Did anybody think of another factorization we could use with another square number that wasn't as big as 36?
9 times
Okay, we'll put and make a note of that one over there, and we'll just see what happens in a minute if we use this one. So over here, if you're square rooting two numbers multiplied together, you can square root each one individually and times together. Square root of 36 is 6. 6 times by root 2. We don't bother writing the times sign in. It's 6 root 2. If we had done it using Patrick's way over here, I could have rewritten that as the square root of 9 times the square root of 8. 9 square rooted is 3. Square root of 8, we worked out what the square root of 8 was earlier in today's lesson. Can anybody just look in the notes? What was the square root of 8 when it was simplified? Emily? 2 lots of root 2. Okay, that comes from earlier. 3 lots of 2 is 6. 6 lots of root 2. We would have got to the same answer. It's just if you can find a big square number, it just makes life a little bit easier and quicker. All right, stopping that video there, and we'll start another one in a minute.